All right, so we're going to talk about, so we're in Unit 2, and we're actually in Lesson 2, and we're going to talk about parallel lines and transversals. Now, parallel lines are two lines that never intersect, and they're completely parallel. And a transversal is a line that cuts in between those two parallel lines. So if you can see here, we've got two parallel lines, and then we've got a line that cuts those two parallel lines in, that goes through those two parallel lines, and that's what's called your transversal. So we're going to look at a couple things. We're going to look at what type of angles do two parallel lines and a transversal make. Okay, so the first thing we're going to look at is postulate number 1, which is corresponding angle postulate. Now, corresponding angle postulate means that this angle right here was called exterior. So when you're looking here at this diagram, the outside here, these two outside, these are your exterior parts. And in this part, we've got what's called interior, and this part is the inside of your two lines, and angle 1 would be on the outside of your two lines. So the outside is actually called your exterior, and the inside is actually called your interior. Now, angle 1 out here is on the outside, and angle 2 is on the inside. Now, if you've got an angle on the outside and an angle on the inside, and they're on the same side, they're called corresponding angles. And corresponding angles are actually equal to each other. You can think of copy and pasting. So you copy angle 2 and you paste it to the outside, which is angle 1. These two angles are called corresponding angles. They correspond to each other. And angle 1 is going to equal angle 2. Let's go down here to alternate interior angles. Now, the reason why they're called alternate is because angle 3 is on one side and angle 4 is on the other side of the transversal. So they're on alternate sides. And they're also on the inside of your two lines. So angle 3 and angle 4 are alternate interior angles, and angle 3 is actually equal to angle 4. Let's go down to alternate exterior angles. Now again, why are they called alternate? Because angle 7 is on one side of the transversal and angle 8 is on the other side, so they alternate. Now, why are they called exterior? Because angle 7 and angle 8 are both on the outside, so alternate exterior angles. The next one, and then angle 7 and angle 8 are equal to each other. And also with the alternate interior angles, angle 3 and angle 4 are also equal to each other. Now let's go down to same side interior angles. Now same side interior angles means that they're on the same side, so angle 5 and angle 6 are on the same side of the transversal. They're on the inside of your two lines, so they're called same side interior angles. Now, both of these, angle 5 and angle 6, also are what's called supplementary. And supplementary angles add up to equal 180 degrees. Also, you can see that both of these angles make a straight line. And a straight line equals 180 degrees. So angle 5 plus angle 6 equal 180 degrees. Okay, so now you know the four main types of angles that are cut by a transversal. You have corresponding angles, you have alternate interior angles, alternate exterior angles, and same side interior angles, also known as consecutive angles. So let's go ahead and go over, and let's look at example number 1. Now example number 1 says, given that measure of angle, it's given to you that the measure of angle 5 is 65 degrees. So now you need to find the measure of each of the other angles. So let's go ahead and look at this. So I went ahead and drew this out for you. So angle 5, 6, 7, 8, and 9. So now angle 5 was given to us, and that was 65 degrees. Now, if you think back to your postulates, Angle 6 actually is what's called a vertical angle. And vertical angles mean that they're vertical. These two angles are literally vertical to each other. So vertical angles are actually congruent. So angle 5 and angle 6 are going to be congruent, which means that angle 6 is going to also equal 65 degrees. Now angle 7. So angle 6 and angle 7 form a straight line. So they're supplementary or linear pairs. So angle 7 and angle 6 are both going to equal 180 degrees. And if we know that angle 6 is 65 degrees, we're just going to take 180 degrees minus 65 degrees is 115 degrees. So that means that angle 7 is going to equal 115 degrees. Now angle 9 and angle 7 are alternate exterior angles. And if you can remember, let's go back to our notes. Alternate exterior angles are equal to each other. So that means that if angle 7 is 115 degrees, angle 9 is also 115 degrees. Now, angle 6 is 65 degrees. We already knew that. Now, angle 8 and angle 6 are alternate exterior angles. And again, alternate exterior angles are equal to each other. So that means that angle 6 and angle 8 are equal to each other. So angle 6 is 65 degrees, so angle 8 actually should equal 65 degrees. So angle 8 would also equal 65 degrees. Okay? All right, so let's go ahead and we can get we'll go ahead and start with a new board. So now, as I'm doing these examples, you should also be doing these with me on your notes page. So let's go ahead and go down to example number 2. Now it says find the missing angle if possible. So let's go ahead and draw this out. So I'm going to draw it out. You can actually just do it on your notes page. You don't need to draw it separately. So we've got two parallel lines and a transversal. So two parallel lines, make that more parallel. They're not going to be drawn perfect, just don't worry about that. So two parallel lines, and then we've got our lovely transversal here. Okay, so here we've got 1, 2, 3, and 4. So let's write that out. So 1, 2, 3, and 4. Oops. And 4. Now angle 1 is 40 degrees. Okay, so that's given to us. And then they want us to find the rest of them. So they want us to find angle 2, 3, and 4. So let's draw this out. Let's write this out. Angle 2, angle 3, and angle 4. Now, we can start with a couple things. I'm going to start with angle 1 and angle 4 are what we call alternate exterior angles. So we know that angle 1 and angle 4 are equal to each other. So if angle 1 is 40, then angle 4 is also going to equal 40 degrees. So now if angle 4 is 40 degrees, angle 3 and angle 4 are what we call consecutive angles. So that means angle 3 and angle 4 also equal to each other because they're consecutive angles. So that means that angle 3 is also 40 degrees. Now angle 2 and angle 1 are supplementary angles, which means that they form a straight line, so they equal 180 degrees. So angle 1 is 40 degrees plus angle 2, and both of those are going to equal 180 degrees. So all we're going to do is we're going to go ahead and subtract 40 and subtract 40. Okay, and these are going to go ahead, they're going to cancel each other out, and then we've got angle 2 is equal to 140 degrees. All right, so then angle 2 would equal 140 degrees. Okay, all right, so that's example number 2. Now, let's look at example number 3. So we're getting a little bit harder here because now we're not just naming angles. It says that you need to actually use the properties of parallel lines to now find the value of x. So again, let's go ahead and draw this out. So we've got two parallel lines and a transversal. So let's go ahead and draw that out. Again, you don't need to draw it out because you have it right in front of you. So let's go ahead and I will draw it out. So we've got a parallel line and a transversal. And then we've got 125 degrees up here and 5x plus 25. So 125 degrees. And down here we've got 5x plus 25 degrees. Now if we go ahead and look back at our properties, we can see that these two angles are alternate exterior angles. Again, they're on alternate sides of the transversal and they're on the outside. So alternate exterior angles, if we look, they are actually equal to each other. So we're just going to go ahead, set this up, and set 125 degrees equals 5x plus 25. So we're going to go ahead and we're going to subtract. We want to get x by itself because that's what we want to solve for. So we're going to go ahead, we're going to subtract 25 from both sides. And we get 5x is equal to 100 degrees. And then to get x by itself, all you're going to do is you're going to do the opposite. So if this actually reads 5 times x, the opposite of multiplication is division. So 5x divided by 5, you're going to go ahead and you're going to divide by 5. And then your x is going to equal to 20 degrees. So your x is 20 degrees. Okay. So now let's go ahead and go to example number 4. All right, so we're going to go ahead, I'm going to go ahead and do example number 4. And then I want you at home to do example number 5. And then you're just going to go ahead and you're going to stop there. So you're actually not going to do the proving angle relationship. So you're actually not going to do those two. You're just going to stop with example number 5. So I'm going to go ahead and do example number 4 with you, and then you're going to do example number 5, and then you're just going to go ahead and stop there. So this says, use properties of parallel lines to find the value of x. So we've got 125 degrees here, and then we've got x plus 15 degrees here. So let's go ahead, I'll go ahead and draw this out. All right, so we have two parallel lines and a transversal. So two parallel lines, a transversal, and then we have, let's see, 125, angle 4, 125, angle 4 here. That's angle 4, it doesn't equal 4, and then we've got x plus 15, and we need to solve for x. So x plus 15. So now we see here that angle 125 and angle 4 are what we call corresponding, so they're actually consecutive angles. So let's go back up to our properties. So they're actually corresponding angles. They correspond to each other. And angle 1 equals angle 2. So angle 4 equals 125 degrees. Now, if you recall, these two angles are supplementary because this angle and this angle both are going to, both those angles form a straight line. So you would set it up to 125 equals x plus 15.